and Communication Technology presents Educational Satellite Television Programs.
Hello teacher, hello students. Welcome to today's lesson, continuing our studies on the properties of vectors in coordinate space. Today we will learn more about the magnitudes of vectors and how to calculate the angle between two vectors in space. Are you ready, students? Let us begin. Observe this diagram. The arrowhead represents the direction of the vector. The length of the arrow represents the vector's magnitude. Therefore, to find the magnitude of a vector, we must find the distance between its initial point and its terminal point in coordinate space. For example, here is a vector which terminates at point P. As you can see, it extends from the origin to coordinates 5, 2, and 3. The vector's magnitude is the distance between point O and point P. What is the magnitude of this vector? Students, take a few moments and answer this question.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am confident that you did not find this question at all difficult, as you remember this material from previous grades. The magnitude of this vector is the distance between O and P. We can determine the distance by calculating the square root of the sum of the squares of the three coordinates. In this case, that means the square root of 5 squared plus 2 squared plus 3 squared. In other words, the magnitude is the square root of 38. What can we conclude from this exercise, students? We have found that if the initial point of a vector is at the origin and its terminal point is at a given point Q, or if each of the terminal coordinates is multiplied by unit vectors I, J, and K, then the magnitude of that vector is given by this formula. If the initial point of the vector is at a given point P and the terminal point is at Q, then we can use this formula instead. Please make a note of this. Let us apply these formulas in an activity. Observe these two vectors. The first vector has its initial point at the origin. The second vector does not. Using what we have learned, please calculate the magnitude of both vectors. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I hope that we were able to calculate the magnitude of these vectors. If you used the formulas, it should not be too difficult. Since vector A begins at the origin, we find its magnitude by finding the root of the sum of its coordinate squares. In this case, the magnitude is equal to the root of 25 plus 16 plus 9. That means it is equal to the square root of 50, or 5 times the square root of 2. Vector PQ is a bit more tricky. As you can see, students, its initial point does not lie at the origin. Luckily, we have learned the formula to make this problem simple. We must subtract each of the coordinates of the second vector from those of the first vector, like this. That means we are subtracting -5 from 1, 0 from 2, and 5 from 0. As a result, we must find the root of the sum of 6 squared, 2 squared, and -5 squared. The magnitude of vector PQ is the square root of 65. If those were your answers, well done. We have only one topic left to cover in this unit, students. We must learn how to calculate the angle between two vectors in space. As we learned in the last lesson, this equation, which lets us find the dot product between two vectors that have their initial point on the origin, can be rearranged like this to help us find the angle between the two vectors, provided they are non-zero. Let us try a simple example to illustrate how to use this formula. Here we have two vectors. Each begins at the origin point. Vector A terminates at coordinates 1, 0, 1. Vector B terminates at coordinates 1, 1, 0. Let us find the angle between these two vectors. The scalar product of both vectors is equal to 1 times 1 plus 0 times 1 plus 1 times 0. In other words, it is equal to 1. The magnitude of vector A is the square root of the sum of the squares of 1, 0, and 1. Therefore, the magnitude is equal to the square root of 2. we calculate the magnitude of vector b in the same way. It is equal to the root of the sum of the squares of 1, 1, and 0. Thus, it is also equal to the square root of 2. The cosine of the angle is 1 over the root of 2 multiplied by the root of 2, or 2. A quick check of our tables tells us that a cosine of 1 over 2 means an angle of 60 degrees. We have calculated the angle between the vectors. Well done, students. That brings us to the end of this unit, students. We have learned all about the properties of vectors and even the equation of a sphere. I hope you have enjoyed learning about coordinate space. Until next time, thank you, teacher. Thank you, students.